So today I'm going to be explaining how to find the power of a matrix. So I'm going to explain this using an example, and I'm going to use a 3 by 3 matrix. But then even if we have a 2 by 2 or a 4 by 4, it's still the same procedure. So in order to find the power of a matrix, we first have to rewrite this matrix A in this case in the form S times D times S inverse, where S is a matrix containing the eigenvalues of matrix A, and D is a diagonal matrix containing the eigenvalues of matrix A in its diagonal. And S inverse is just the inverse of matrix S, the one that contains the eigenvalues of matrix A. So with that said, I've already drafted the solution, so I'm just going to be going through it and explaining each step. So the first things first is to get the eigenvalues and eigenvectors of matrix A. As you all know, to get the eigenvalues, we say we're going to find the determinant of A minus lambda I, which is our identity matrix, and so you follow that entire process, and then you're going to find that your eigenvalue is lambda 1 is 8, lambda 2 is 2, lambda 3 is minus 8. I'm sure that most of you are comfortable with finding the determinant of this. So with that said, the next process is to find the eigenvalues, and to find like eigenvalue v1, we just substitute lambda 1 here, just like here. What I've already written here. So it's just gonna be a minus lambda 1I v1 equals to vector 0, and our v1 should not be equals to 0. So you do the same process for like each lambda. For like lambda 2, you do the same process. You just substitute here. Instead, you now put v2. You solve for like v2, and then you're gonna find that your eigenvalue here is gonna be minus 1, 1, 0. You do the same process for like lambda 3, and you get this as your eigenvalue. Now matrix D, which is it contains our eigenvalues in its diagonal. So our matrix D becomes this matrix here, because we just substitute 8, 2, and minus 1 in the diagonal. And matrix S contains the eigenvalues, which is v1, v2, v3, and then you substitute them in here, and you're gonna get this as your matrix S. Now we're gonna have to find our matrix S inverse, which is, I'm sure most of you all are familiar with the process of determining an inverse, which you have to turn this matrix S into an identity matrix, and this matrix that you're gonna have here, it becomes inverse S. Yeah. So you do that process, you're gonna find that S inverse is this. Now then everything just falls into place, because now we have A into this. Now we substitute these matrices. Well, you can leave it in this form, or you can just multiply all of these matrices to like a single matrix, so that when you want to find the power of A, you just substitute there, and then you can easily work out everything. So A to the power of n, in this instance, where n represent like power that we want. For example, n2, where n is 3, n is 4, and so on. So this n, you're gonna square these eigenvalues in the diagonal matrix, which is our matrix B. So now if like you multiply all of these matrices throughout, you start here, you find one matrix and then you multiply it with that, and then you're gonna find that the final form of our matrix A is this. So now we can find any power of A that we want. You can test it by like putting in 1 to just check if this is correct. Remember, we have our A here, and this A is to the power of 1 already. So if like you put 1, you will find out that all of these things like boil down to just these values. So after here, you can like find out any A that you want, whether you want to find a 100. You just put in 100 here, 100 there, 100 there, 100 here, wherever there's like n, you just put this 100. Whether you want to find a 19, so forth. So you can just put everything here and here, and that will be all. If like there's any part that you did not understand, you're welcome to comment below, and I'll gladly reply to your comment. Thank you.